Okay, hello Mathcounts friends. Today is another Mathcounts Foundations video, and for this session we're going to be looking at coordinate geometry. So let's go ahead and jump in. These are some easier problems. They're actually not too easy, but some of them anyway. But please pause the video here and try to work these out on your own, and then I'm going to provide the answers. So I assume that you have paused now. I'm going to reveal the answers in 3, 2, 1. There you go. All right, now we're going to work these ones out. So let's jump right into it. So this one says, what is the y value of a point of intersection, the point of intersection of two lines with equations y equals minus 3x plus 2, and then y equals 4/7 x minus 6. You want to express your answer as a decimal to the nearest hundredth. So one way to do this is to set these two equations equal to each other. Because we know that at the point of intersection, so whenever you have an equation like this, it's a linear equation, which means that if you graph it, it's going to look something like this, right? So this is an equation y equals some slope times x plus some intercept. So it's of this form, y equals mx plus b. That's what these two equations are both in a form like this. And if you have another equation, which is graphed here, it will have, its equation will be the same form, but just with a different m and b. So it'll be m, let's just call this one m2 maybe, m2x plus b, 2. So they just have a different m and b. It'll be a different line. So every line pretty much can be written in this form. You can't really write vertical lines in this form, but any other line you can write in this form. And where they intersect, this special point here where they come together, that is going to have some coordinates x and y. And if you plug those coordinates into either equation, the equation will work. And so when we look at these two equations and it asks us the y coordinate of the point of intersection, we know that that the same xy pair will be able to work in both of these, and we just need to find the y value. Now if we set these two equations equal to each other, because we know the two y's are the same, we could then solve for x. Or we could solve these equations for x each independently and then set those two equal to each other. And then we would directly get y. I guess there's pros and cons to those two approaches. But maybe I'll take that first approach since even though we'll have to plug in, we'll get the x value with that approach, and then we'll have to plug it into one of the two equations to get the y value. But at least I won't have to solve both of these equations for x up front. So that's kind of the trade-off here. So let's set these two equal to each other. So this is minus 3x plus 2. That's the y for this equation. And that's going to be equal to the y for this equation, which is 4/7, 4/7 x. That's not, let me fix that a little bit. 4/7 x minus 6. So these are equal to each other. Now I just need to solve for x. Maybe just to get rid of this denominator, I'll multiply everything by 7. So this is going to be minus 21x plus 14 equals 4x minus 42. And if I put all the x's on one side, I'm going to get, well, let's move it onto this side. And we'll move the constant values over here. So I'm going to add 42 and 21x. So this is going to give me 14 plus 42, which is going to be 56. And that's going to be equal to, let's see, I was adding 21x plus 42. So now I'm going to have 25x. So my x value is going to be 56 over 25. And now I can plug that x value into one of these. I think I'm going to pick this one. It seems a little easier. So I get y equals minus 3 times that x value, which is 56 over 25. So these are getting multiplied by each other. And then I'm going to add 2 to that, all right? Okay, so this gets a little bit messy here, but what do we get? We get let's see, this would be 150 and 18. So that'll be 168, negative 168 over 25 plus 2, which if I put it over 25 is 50 over 25. So this is going to be equal to negative 118 over 25. So that is our answer, but they want it as a decimal to the nearest hundredth. So let's go ahead and convert that to a decimal. Well, what's the integer part going to be? We're going to have a negative 4, and then we're going to also have a negative 18 over 25. So that'll be 1 over 25 is 0.04, so I need to multiply that by 18, and I'm going to have the negative of that. All right, so that'll give me, let's see, this will be 0.72, right? So that'll be negative 4.72. So that's going to be my final answer on that one. Okay, very good. Let's move on to the next one. All right, so this one says, if the point 89 is the center of a circle of radius 10 units, at how many points does the circle intersect the coordinate axes? Okay, so let's draw some coordinate axes. We've got a y-axis and an x-axis. And then we've got the point 89. So we go over to 8 and up to 9. And there we get our center of our circle. And it says the radius is 10. So what I think is useful is to think about how many times that circle is going to intersect each axis separately. So how many times is it going to intersect the x-axis? How many times is it going to intersect the y-axis? And because that radius of 10 units is bigger than 8, that means the circle is going to intersect the x-axis twice. And because it's bigger than 9, it's also going to intersect the y-axis twice. So the only remaining thing we have to be careful about is if these intersections happen at the same time. Like, for example, if it hits the origin, 0, 0, then you would have to subtract 1, right? Because it would hit the x-axis and the y-axis at the same location. And then instead of having 4 intersection points, you'd only have 3. But this distance from the origin out to 8, 9 is not a distance of 10, right? Because 8 squared is 64, 9 squared is 81, and if you add those two together, it's not going to give you 10. This is bigger than 100, right? The 64 plus 81. So that means that these 4 points, the 2 at which it intersects the x-axis and the 2 at which it intersects the y-axis, are going to be 4 distinct points. And so our answer is just going to be 4. That's the number of points at which it intersects the coordinate axes. Axes is the plural of axis. We've got the x-axis and the y-axis. That forms your coordinate axes. Okay, great. So that's the answer there. Let's go on to the next one. And this one says, what is the distance between points negative 1, 15 and 8, negative 3? And express your answer to the nearest whole number. Okay, so we could graph this, I suppose. There's not a lot of benefit to graphing it, but we'll do it anyway. So we've got an x-axis and a y-axis, and we've got a point at negative 1, 15, so it's way up here. So this is negative 1, 15, that's one point. And the other point is at 8, negative 3. So we go over to 8, say this is 8 in x and negative 3 down here. And that gives us this point, 8, negative 3. And the question is, what's the distance between these 2 points, right? So if you were to draw this line segment that connects negative 1, 15 to 8, negative 3, what would that distance be? And the important thing to realize here is that there is a triangle that we can draw that goes straight down here, and then straight over here is a right triangle. And because it's a right triangle, we can use the Pythagorean theorem to compute this distance by finding the height of that right triangle and the base length of the right triangle, squaring each of them, adding them up, and taking the square root. So what does that give us? This is from negative 3 up to 15. That's a distance of 18 is the height of this triangle. And then from negative 1 over to 8, that's a distance of 9. So what we're going to have is the square root of 18 squared plus 9 squared. And we can take out, let's see, we can take out, well, we can simplify this a little bit. We can say this is 9 squared times 2 squared plus 1. And then we take out the 9. That gives us, let's see, did I do that right? 9. It's going to be 9. 9 times the square root of 4. This is 4 plus 1, which is 5. 9 times the square root of 5. Okay, and it wanted us to express the answer to the nearest whole number, which can be a little tricky without a calculator because it's hard to know the square root of 5. So really, to do this problem, you kind of have to know that the square root of 5 is about 2.2. Or you could break out your calculator and just figure this out and round it to the nearest whole number. But if you have 9 and you multiply it by 2.2, let's see, you're going to get 18, 19. Yeah, you're going to get 19.8. And 19.8, if you round it to the nearest whole number, that is going to be 20. So 20 is our answer here. That was a tricky one, I think, because not everybody knows that the square root of 5 is about 2.2. You know, it's a bit bigger than 2. So, you know, if you had 2 here, that would be 18. And maybe you could try a few things and see. You could try multiplying 2.2 or 2.3 by themselves and see which one gives you closest to 5 if you didn't remember that the square root of 5 was about 2.2. All right, let's go on to the next one. This one says, a triangle has 3 vertices given by coordinates 2, 2, 2, negative 6, and negative 5, negative 9. Okay, so this point is 2, 2 on our coordinate axis. The other one is 2, negative 6, which will be, let's see, that'll be the same x coordinate, but it'll be down below, so that'll be 2, negative 6. And then we have a negative 5, negative 9. So that's going to be, well, it's going to be somewhere way down here. I guess I should have left myself more room down here, but let's just put it here. Negative 5, negative 9. And let me write that so we're not going to get in the way. Negative 5, negative 9. It's not going to get in the way as I draw these line segments connecting them, because I've got a triangle here, and they want to know the area of this triangle. Now there's a couple different ways to do this. One way you could do it is with the shoelace theorem, and another way you could do it is by using the formula for a triangle, which is 1/2 the base times the height. Now you have to be a little careful because it's going to be hard if you call this edge the base. It's going to be kind of hard to figure out the height, and if you call this edge the base, it's going to be kind of hard to figure out the height. You know, this height here with a perpendicular here, or this height here with a perpendicular here. So the best thing to do is to call this one the base, because it's already straight vertical. It's maybe more natural to think about a base as being horizontal, but here we've got a vertical segment, and so the height is going to be straight along the x-axis. This is going to be our height of our triangle. You kind of have to turn your head 90 degrees to think about this as the base and this as the height. But that's how we can do it. And this base is just going to be the difference between the negative 6 and the 2, which is 8. And then the height is going to be the difference between the 2 and the negative 5, which is 7. So this 1/2 base times height is going to be 7 times 8 divided by 2, which is going to be 7 times 4, which is going to be 28. So that's our final answer. I do want to show you how to do it with the shoelace theorem also. So let's maybe make a little bit of room here, and we'll do it with the shoelace theorem. With the shoelace theorem, we don't need a graph at all. We just write down the coordinates and do some computation. So I'll show you how that works. I did make a video describing the shoelace theorem and proving why it works. But basically what you do is you take these coordinates up here, 2, 2, and you write them vertically like this. And then the next one, 2, negative 6. And then the next one, negative 5, negative 9. And you can do this for any polygon and compute the area of any polygon given the coordinates. The only thing you have to be careful about is to make sure that you go in order. So if you have a quadrilateral, for example, you don't want to list these coordinates like A. Like if this is A, B, C, D, you don't want to list A, B, C, D. Well, no, you do want to list A, B, C, D in that order, or you can go the opposite order, A, D, C, B. As long as you're doing neighbors together, you should be fine. But if you skip around and do A, C, B, D, you're going to get the area of this like one of these triangles minus the other or something. It's going to be weird. So you need to make sure you do it in the right order. And what you do is you put the first, and if it's a triangle, it doesn't matter, because no matter what order we do it in, it's going to be either clockwise or counterclockwise. So we're not going to worry too much about the order. But what you do is you put down the coordinates of the first point, and then the second point, and then the third point, and then you repeat the first point again. Okay, so this 2, 2 gets repeated. So just the first point gets repeated at the end. And then you build your shoelace. So this is why it's called the shoelace. You go down in this direction, like that, and then you do up in this direction, like that. And it sort of looks like some shoelaces here. And what you're doing is you're multiplying. Okay, so you're multiplying 2 and negative 6, that gives you negative 12. Whoops, negative 12. And then you multiply 2 and negative 9, that gives you negative 18. And then you multiply negative 5 and 2, that gives you negative 10. And then you go and you do it the other way. Okay, so you do 2 and 2, that gives you 4. Negative 6 and negative 5, that gives you 30. And then negative 9 and 2, that gives you negative 18. Okay, and then you add these all up. So 34 minus 18, that's going to give you 16 if I'm not mistaken. So we got 16 total with adding these three together. Let's see. Did I do that right? This is going to be, yeah, this should be 12 and 4, yeah. And then down here, this is negative 30, negative 10. This is going to be negative 40. Negative 40. And that's what you get here. And then the last step is to subtract these two numbers. And you want to subtract them in such a way that you get a positive number, because you want your area to be positive. So we're going to do 16 minus negative 40. So that's going to be 56. And then the last step is you divide it by 2. And that's going to give you your 28. So either way works. In this case, we had a nice vertical line between these 2 points, which, whoops, one sec. Okay, sorry about that. So yeah, since we have these 2 points that are straight up and down, it was easy to compute the base and then the height. But if there wasn't a segment of your triangle that's straight up and down or straight horizontal, then sometimes the shoelace theorem is an easier way to compute the area. All right, great. It's time to move on to our medium problems. So here they are. Please note that you can use a calculator on this one here. So pause the video and work them out on your own, and then come back to see the answers. Okay, I'm going to assume that you're here to see the answers now, and I'm going to show them in 3, 2, 1, go. All right, there we go. We've got 4, 10, 4, 45, and 24. So let's go ahead and solve these problems, starting with this one. All right, this one says square ABCD in the coordinate plane has vertices A, which is at 2, 4, B, which is at P0, C, which is at 2, negative 4, and D, which is at Q0. Okay, so a couple of these are variables, P and Q. And then they want to know the value of P plus Q. Okay, let's take a look at this. So A, we've got our coordinate axes here. Let's draw our y-axis and our x-axis. Okay, and then let's go ahead and draw some of these points. So 2, 4, it might be here. So this is 2, 4. That's one of our points. Another point is at P0. Okay, so all we know is it's somewhere on the x-axis here. We could put it to the left or to the right. We don't know yet. And then we have C is at 2, negative 4. Okay, 2, negative 4. That's going to be down here. 2, negative 4. And then the other one is at Q0. Okay, so both of the other 2 points are somewhere on the x-axis. And you'll notice that as long as these are in order, A, B, C, D, then this is going to be a diagonal of the square here. So this square is actually tilted at a 45-degree angle because its diagonal is vertical, which means we've got a point somewhere over here and another point somewhere over here. And we know that the center of those two has got to be here because the two diagonals of the square have to meet. The center of the two diagonals are going to meet. And so what we can figure out then is that this point P0 over here and this point Q0, well, what we know is that this distance is going to be equal to this distance, which is going to be equal to this distance, which is going to be equal to this distance, meaning the distance between these 2 points is 4, right? So we got 4 here. The distance between these 2 points is also 4. The distance between these two is going to have to be 4, so that's going to put this up to 6, 0. And then the distance between these two, so this one's going to be -2. And what do they want? They want P plus Q, so that's going to be -2 plus 6, which is going to be 4. All right, so another way to think about it, if you don't even actually need to figure out these values exactly, you can figure out that the average of those two values is going to be here at 2, 0. And then since the average is at 2, 0, the sum of them has to be twice that amount, which is 4. I mean, the sum of the two x coordinates is going to have to be twice this x coordinate. So that'll be 4. All right, great. Let's move on to the next one. This one says the line y equals 2x plus 3 is parallel to a line that goes through 3, 2 and 7, c. What is the value of c? Okay, so y equals 2x plus 3 is parallel to a line that goes through this point. So what does it mean to be parallel? Well, when you write it in this y equals mx plus b format, the slope is this value here, this m value of 2. And if you have a line that's parallel to it, it will have the same slope. So this line that's parallel to it is going to be y equals 2x plus something, some b value. And we don't know what that something is yet, but we know that that line goes through this point, 3, 2. So we can plug 3 and 2 in here. And let's see, so y is 2, and that equals 2 times x, which is 3, plus b. So if we solve for this, that's 2 equals 6 plus b, and then b equals -4. Okay, so now we know that this line that they're talking about here has the equation y equals 2x minus 4. And it says the line is parallel to a line that goes through this point and this point. And then they want to know the value of c. So we know that this point is also on the line. So we can plug that in for x and y. 7 is our x value, and c is our y value. So you can say c equals 2 times 7 minus 4. And so this is going to be 14 minus 4 is equal to c. And so that means c is equal to 10. And what do they want to know? They want to know the value of c. So 10 is our final answer on this problem. Okay, let's move on to the next one. And this one says, what is the maximum value of the function f of x equals, and I give you this quadratic equation here. And they've got a plot of it over here. So the maximum value is going to be at what we call the vertex up here. And you can always find the x-coordinate of the vertex as minus b over a. What do I mean by b over a? So this is a quadratic formula, which means it's of the form ax squared plus bx plus c is equal to, that's it. Ax squared plus bx plus c. And when you solve for the roots, which is the points at which it is equal to 0, you would set this equal to 0, and you would use a quadratic formula, which says minus b plus or minus the square root of b squared minus 4ac over 2a. Make this square root go all the way over. Okay, so this is a quadratic formula. And what this is it's, if you could expand this, you could write this as minus b over, oh, I'm sorry, this was supposed to be minus b over 2a. So this is minus b over 2a plus and minus some other thing, right? And the other thing is this part here. But what I want you to realize is that you're adding and subtracting this same thing. And so that's going to sort of take you to these 2 points at which it hits the 0 axis. So that means the thing that the place that you were starting from before you did the plus and minus something must be right in the middle of those 2 points. And that corresponds to the x coordinate of the vertex of the parabola. So if you want to know the x-coordinate, which is the point at which the maximum value occurs up at this vertex, the x-coordinate of that is just going to be this minus b over 2a. And in our case, that will be minus 2 divided by minus 2, because b is 2 and a is negative 1. So we're going to have minus 2 over minus 2, which is going to be equal to 1. And we just plug 1 in for x to find out the function value at that point. Because they didn't ask us what is the x-coordinate, they asked us what is the maximum value of the function. But if we plug in 1 to this function, we'll find out the height of that parabola at that point. So we plug it in. We do minus x squared plus 2x plus 3. We plug in 1 there. Minus x squared is going to be minus 1 plus 2x is going to be plus 2. And then plus 3, this is going to be 4. That's going to be our final answer on this one. Okay, let's go on to this next one. This one says, how many ordered pairs A, B of positive integers with a plus b equal 110 satisfy a times b is greater than or equal to 2500? Okay, so this is a tricky one, I think. Let's go ahead and start thinking about some of the ideas here. The first thing is, what does it mean for a plus b to be 110? If we graph this and say this is a and this is b, a plus b equal 110, that can happen up here, for example, at 0, 110. It can happen way down here at 110, 0. Those are two examples of points on this line, and there are even some negative values as well. This line that goes through these 2 points, I didn't draw that quite right. Let's see, this line that goes through those 2 points, something like that, is gonna look something like that. And all the points A, B, anywhere on this line, even back here or down here, they're all going to satisfy this equation, a plus b equals 110. And so what we need to think about is, what is a times b for all these? And one thing I like to point out here is that if you have a point AB on this line, the product of that is going to be the area of this rectangle between that point and the origin. Okay, so if you form that rectangle there, that's going to be the product of A times B. And so this rectangle is going to get really skinny as you go up toward this point here. And actually, it's not true that it's the area of the rectangle once you go past this axis, because then that product becomes negative actually, and the area can never be negative. So only within this first quadrant here is that true, that the product of A and B is the area of the rectangle. But that's all we need to worry about, because when it's negative, it's definitely not going to satisfy this equation. So we're only going to worry about the part in between these 2 points. And so as you move your AB point closer and closer up here, that rectangle is going to get really skinny and the area is going to be very small. As you go right to the middle here, like for example, this would be 55, 55, right? That is going to give you your biggest area, because that's going to be a square. And that's just the way to make the biggest area when you have the sum equal to 110. And then as you go down in this direction, the rectangle is going to get really skinny again, and the area is going to be small again. So if you were to plot the area for all these points, it would, as you move the point along this segment, the area would get bigger and bigger and bigger. It would max out here, and then it would get smaller and smaller and smaller. So we want to know how many of those pairs of integers are going to satisfy this equation where it's bigger than 2500. And I think I said you could use a calculator on this one. So let's go ahead and grab our calculator. I have Python here. Let me go ahead and grab that. I think what's going to happen, because of the symmetry of this thing, there's going to be some point at which that area goes up above 2500, and then it's going to stay above it, and then the symmetrical point on the other side is going to go below, right? Because it's going to be some A and 110 minus A, at which it finally gets above 2500, and then there's going to be some point 110 minus A or yeah, well, this a, this will be 110 minus a, and then this will be a here. At that point, it's going to go the other direction. So let's just try some things. I guess you might think, well, what if we did 75 for a? So 75 times 35, that adds up to 110, right? Or maybe I'll just do it this way. I'll put 110 minus 75. And that'll give me 2625. Okay, so that is already above my 2500, right? So I can go maybe down a little bit. Let's try 70. Okay, that's below. So I can just kind of say, okay, it's got to be bigger than that. 71. Oh, wait, hold on. I forgot to, nope, I did that wrong. I've got to change both numbers here. So 71. Oh, that's also bigger. 70. That's bigger. Oh wait, I need to make. Oh no, I need to go higher, right? So let's try 80 for both of these numbers. Okay, that's below. So let's try 77, and that's still above. So let's go to 78. Okay, that one is below 2500. So 77 is going to be the last one. 77 is going to be the last one. And what is 110 minus 77? That's 33. So 3377 is going to be above, let's see. So let's go back to our graph. So this point, when this section here where it's above that value is going to be from this point, 3377, all the way to this point, which will be 7733. And then there will be a bunch of points in between, right? Anytime you add one, so for example, 34, 76, 35, 75. All these ones all the way up to 77. So basically the x-coordinate can be anywhere from 33 up to 77. And how many points is that from 33 up to 77? You need to take 77, subtract 33, and then add 1. So that's going to give us 45. So there are 45 of these coordinate pairs, these points at which we're going to have this above 2500. I hope that made sense. All right, let's go ahead and move on to the next one. This one says, as shown in the figure, the parabola given by the equation, and then they give us an equation here, intersects the x-axis at points A and B, okay, A and B. And its y-intercept is at point C. And then they ask us, what is the area of triangle ABC? Okay, so first thing we need to do is find the x-coordinates at which it intersects the, the points at which it intersects the x-axis. And then we also need to find the point at which it intersects the y-axis. And you have to be a little careful here because in the process of finding these 2 points, A and B, you might scale this equation. For example, I might look at this and say, okay, first I'll set it equals 0. 0 equals minus 1/2 x squared minus 2x plus 6. And I might say, oh, well, let's multiply this by -2 so that we can get, our x squared term to not have the coefficient to be 1. And if I do that, I get 0 equals x squared, and I multiply everything by -2. That will give me a plus 4x minus 12. The problem is this is now a different parabola. So I have to be careful not to use this parabola to find the point C. I can only use it to find the points A and B, because when I multiply this thing by -2, I got a parabola that's going like this or something, But it has the same, whoops, I didn't draw it perfectly, but it has the same A and B, still didn't draw it, but it has the same A and B intersection points on the x-axis. And that's what's important. And so we can factor this, or we can use the quadratic formula, but this one is pretty easy to factor. This is just x plus 6 times x minus 2. And that tells us that the points at which we have a 0 are going to be, x has got to be in the set 2 or -6. So it's going to be one of those two. And so that means this distance from A to B is the difference between those two, which is 8. So this thing is 8. And now we need to find the height. So to find the height, we can plug x equals 0 into our quadratic equation. But again, we have to be careful not to use this one. We have to be careful to use the original parabola equation, which is this one. We plug in 0. That's just going to be 0 minus 0 plus 6. So that's going to be 6. So that means this height of our triangle is 6. And now we can just use 1/2 the base times the height, which is 1/2 of 6 times 8, which is 24. So that is our answer to this one. Okay, let's move on to some hard problems. Here they are. I would encourage you to pause the video right now, try to work these ones out, and then come back to see the answers. All right, so I'm going to reveal the answers in 3, 2, 1. There they are. And now let's work them out. So let's start with this one. So this one says, how many points with only integer coordinates lie on the line segment with endpoints 0, 0, and 70, 98. Okay, so we've got a coordinate axis here. We've got the origin, which is at 0, 0. That's right here. And then we've got some point way up here at 70, 98. And they say you've got a line segment that connects those two. And they want to know how many of these points on this line segment are at have integer coordinates. So in other words, you could draw like an integer grid with a bunch of lines across this way for integers and vertically for integers. And they want to know how many times does it get right on one of these crosses where, you know, where both coordinates are integers. And so this isn't really so much of, this is more of a number theory problem, because it turns out that you're going to have some similar triangles when you have exactly integer coordinates. So let's say that we're exactly at an integer coordinate here. What that means is we're going to be able to build a similar triangle. Let me draw it in a different color. We're going to be able to build a similar triangle here, like this. And then the other similar triangle is going to be up all the way to 70, 98, and down like this. And we're going to have, you know, the width of this purple triangle is of course 70, and the height is 98. So we'll have 70 divided by 98 has got to be equal to the coordinates, the ratio of the coordinates here. So this height here will just be your y coordinate at that point, which is, we know is an integer, and this width here will just be our x coordinate at that point. So that's going to be y over x. And so the question is really, how many different ways can we solve this equation? And it turns out that there's going to be one solution, which is the smallest. So you're going to have this smallest triangle here, at which you have this ratio, and that's just going to be what you get when you simplify this fraction to its, you know, simplest terms, right? To a common fraction, basically. So in order to do that, you just need to divide top and bottom until you can't reduce it anymore. So we can divide both top and bottom by a 7, I believe. That will give us 10 divided by 14, which means we can still simplify it more. We can divide by a 2. That will give us 5 over 7. Okay, so the smallest triangle you could have is 5 and 7 here. And then every time you add another 5 and another 7, you're going to get another point. So this first one is going to be at 5, 7. And then the next one here is going to be at 10, 14, right? And so on. You're going to have a bunch of these. And the number of steps you can take to get from here up to here is just whatever you divided by to get from 70 down to 5, right? So we divided by, what was it? We divided by 7 and 2. So we divided by 14. So that means there's going to be 14 steps. So we go from here to here, that's 1. We go from here to here, that's another one. There's going to be 14 of these steps, and at the end of each of these steps, you're going to be at an integer coordinate. Every time you can add 5 and add 7. Add 5, add 7, add 5, add 7, add 5, add 7, add 5, add 7, add 7. You can do that 14 times and you get up to here. So the total number of points is going to be 15. You have to be careful, because if you start, you have to include both the starting point and the ending point, right? So you start with the starting point, and then every time you take a step, you add one more. You did 14 steps, that means you've got 15 points altogether, because this line segment does include the 2 endpoints. All right, so our final answer there is 15. Let's take a look at this one. So this one says the area of the region bounded by parabola, and then they give you the equation for the parabola here. They say, and the line y equal -7 can be determined by using the formula, and then they give you this formula. Area is 2/3 the base times the height, where b is the length of the horizontal base, so that's the length of this thing here. And then h is the vertical distance from the vertex of the parabola to the base. So that's this height all the way from this line all the way up to the vertex here. And fortunately, if you know calculus, you could compute this formula. But since you guys don't know calculus, they just give it to you. So they give you this formula. A is 2/3 the base times the height. All right, so then they ask you, what is the area of the shaded region? Okay, so the area, they gave us the equation. It's 2/3 the base times the height. So we just need to figure out what that base and that height are. I think the easier one is the height, because if you look at this formula here, that is going to have its maximum when x is 0. Because if x is anything but 0, this is going to be a negative. This first term is going to be negative. But if you set it x exactly to 0, then that first term is just going to be 0. So that's going to make this term the biggest it can possibly be. And of course, this term is a constant. So the biggest this whole thing can be is when you set x to 0. And that's going to be 11. Okay, so this point up here has a y-coordinate of 11. That's the distance from the x-axis up to the top. And then the distance down here below is going to be 7, because this is y equal -7. So 11 plus 7 is going to be 18. That's going to be the height. Okay, so our height is 18. Now we need to figure out the base. So the base we can figure out by writing the equation. So we have we have an equation y equals -7, y equal -7. And then we have another equation, which is y equal -2x squared plus 11. And at these intersection points, those two are going to be equal to each other, those two y's. So we can say -7 equals -2x squared plus 11. Another way to do this is to think, oh, if I brought this parabola, if I add 7 to this parabola, those 2 points will just move up onto the x-axis where y equals 0. So I could set it equal to 0 if I add 7 to that. So, but anyway, that's what we're doing here. We add 7 to both sides. We get 0 equals -2x squared plus 18. And this is a quadratic formula. We could use the quadratic formula for this, but I think it's going to be easier to just divide by -2. If we divide by -2, we get 0 equals x squared minus 9. And of course, this is just x plus 3 times x minus 3, or you can just think x squared equals 9, right? When does x squared equal 9? Well, it's going to be when x is 3 or -3. So that means this distance between those 2 points is 6, right? If you've got this, one of them is at +3 and one of them is at -3, the distance between the two is going to be 6. So 6 is our base. Our base is 6. We can replace this with 6. And now, let's see, 2/3 of 6 is 4. Oh, well, that'll do. 2/3 of 18 is 12. 12 times 6 is going to be 72. So our answer here is 72. All right, let's go on to the next one. This one says point A is the point on the graph of y equal -2. Oh, yeah, I'm not even going to read that. It's a big long mess there with some absolute values. So it's the graph of this thing up here with the greatest y coordinate. And point B is the point on this graph with the least y coordinate. And what is the length of the segment AB? So we need to figure out what these points are, A and B. So we can do them each one at a time, right? They're kind of independent problems. So this first one, how are we going to be able to get the biggest possible, the biggest possible y coordinate? So this second term is just a constant, it's 11. And then this term is, the biggest you're going to be able to get this is 0. Because it's a -2 times an absolute value. And the absolute value, the smallest the absolute value can be is 0. So anytime x is anything other than 3, this absolute value is going to be positive, and then -2 times it is going to be a negative number. So the way to get this whole thing as big as possible is to set x equal to 3. And if you do that, you just get y equals 0 plus 11. So that y coordinate is 11. And the x coordinate was 3, right? So our point A is going to be at 3, 11. What about our point B? So our point B is the point on this graph with the least y coordinate. Okay, so this, again, the second term is a constant. The first term, we need to make it as small as possible. And the way we're going to do that is to make this part inside the square to be equal to 0. Because anytime that is anything other than 0, you square it, it's going to be positive, which is just going to make it bigger. So we got to make x plus 7 equal to 0. We're going to do that by setting x equal to negative 7. And if we plug that in here, we get y equals 0 minus 4. So we have our point B is going to be at negative 7, comma, what was it? Negative 4. Negative 7, comma, negative 4. And now they want to know the length of segment AB. That's just the length between these 2 points, which we can use the Pythagorean theorem for. We just take the difference between the x coordinates, which is 10. We square that. And then we take the difference between the y coordinates, which is 15. And we square that. And we add those together, and we take the square root. Now, let's see. I think I can take a 5 out of that. That will give me 5 times, so 5 times the square root of, let's see, this will be 2 squared plus 3 squared. Right, so this is 4 plus 9, that's 13. So we end up with 5 times the square root of 13. And I don't think we can simplify that anymore. So that's going to be our final answer there. Okay, and as a bonus, I've got some more hard problems for you. So let's take a look at those. Please pause the video here. These are the last 3. And I will show the answers. And I'm assuming that you're back ready for the answers now. So I'm going to give them in 3, 2, 1. There we go. All right, so let's go ahead and work these out. Let's start with this one here. So this one says, suppose M is the line given by the equation, this equation, and suppose N is the line perpendicular to M and passing through the point this. And then K is the line of slope 5 and y-intercept 1. Okay, so we've got 3 different lines now. And then it says, what is the x-coordinate of the intersection of N and K? Okay, so we've got these 3 lines. I'm not going to graph how they really are, but we've got these 3 lines. You know, one of them here, another one is parallel to it, and then we've got another one here. So the first one was line M, the second one was line N, and the third one was line K. And I didn't graph them correctly. I just, oh, what is it? The first one is, okay, wait, I said that wrong. The second one is perpendicular. So let me just start over here. So we've got a line M. We've got another one that's perpendicular to it. So this was M. N was perpendicular to it. And then K was some other line. And what they wanted to know was the x-coordinate of the intersection of N and K. So this first line, we don't really need to know too much about it, except we need to know its slope. And that's going to help us to find the slope of line N. And then we can find exactly what line N is by looking at this point here. And then we'll work from there. So, okay, I'm going to erase all that. And we'll just try to figure that out. So let's go ahead and start that. So M is given by this equation. Now you notice it's not in our, it's in a different form. It's not in y equals mx plus b, but we can put it in y equals mx plus b. We can subtract 6x from each side. That'll give us minus 3y equals 7 minus 6x. And then we can divide by negative 3. That's y equals, maybe I'll put the x part first. So this will be negative 6 divided by negative 3, which will be 2x plus 7 over, well, it's negative 7 over 3. But we don't actually care about this. All we care about is the slope of this line. So the slope of this line is 2. And so when it says that line N is perpendicular to this line, that means that line N is going to be y equal negative 1/2 x plus b for some b, because negative 1/2 is going to be the slope of a line that's perpendicular to a line with slope 2. Whenever you have a slope of one line and you want to know the slope of the perpendicular line, you need to take the reciprocal of the negative. So if you start with 2, the reciprocal is 1/2, and then the negative of that is negative 1/2. So this is our line n, and we know that it passes through the point 6, 2. So we can plug that in here. That gives us 2 equals minus 1/2 of 6 plus b. So that means 2 equals negative 3 plus b. So that tells us that b equals 5. Okay, so now we can plug b equals 5 in up here, right? So this is our line n now. We have it completely specified. Y equals negative 1/2 x plus 5. And then the line k has slope 5 and y-intercept 1. So our line k is going to be written as y equal 5x plus 1. And they want to know the x-coordinate of the intersection of n and k. So to find the x-coordinate of the intersection, we can just set these two y's equal to each other, because at the intersection point, the y's will be the same. So now we have 5x plus 1 from this y, and then that's going to be equal to minus 1/2 x plus 5. And then we just solve for x. Maybe I'll multiply by 2 just to get rid of the fraction. So this is going to be 10x plus 2 equals negative x plus 10. And I can add an x and subtract a 2 from each side. That's going to give me 11x is equal to 8. And then I can solve that as x equals 8 over 11. And that's going to be our final answer, because they wanted the x-coordinate of the intersection. So that's all we got there. Okay, let's go on to the second to last problem. This one says, a point D is placed on the segment with endpoints 0, 8, and 8, 0. Okay, let's go ahead and make our coordinate axes here. Okay. And so we've got y, x, and we've got this point 8, 0, and this other point 0, 8. And we've got a line segment that connects those two. So let's do that. And then it says there's another segment that connects these other points. So this is negative 3, 0. Negative 3, 0, that's here. And then 0, negative 2. 0, negative 2 here. So that's our other line segment. Maybe I'll do that one in a different color just for fun. So that line segment goes like that. And now the question is, what is the shortest possible distance between D and E? Yeah, hopefully you can kind of just see that the shortest possible distance is going to be between this point, 0, negative 2, and then a point that is, a distance, a perpendicular distance from this point here. So we want to know this distance here. And there's probably many different ways to do that, but I want to show you an interesting way of thinking about this, I think. So one thing you can realize is that this line segment, or if you think about the whole line, maybe the whole line through that coincides with that line segment, that is x plus y equals 8. Okay? And you might think about, well, what are all the points that are a certain distance away from that line, right? So for example, let's say all the points that are 1 away from that line, they would be in another line that is parallel. So maybe I'll draw that in blue here. So there would be a parallel line here that is exactly one distance in that direction. And I guess there would be another parallel line over here that's one distance in the other direction from that line. So as you go farther and farther out, eventually you're going to get a parallel line that goes through this point. That's not parallel, is it? Yeah, you get the idea. A parallel line that goes through that point, and then eventually you'll get another parallel line. That wasn't quite right, but you'll get another parallel line here that goes through that other point, something like that. And so we can just find the difference, the distance between these two lines. So for example, you could take a function that was x plus y equals 7. That would be a parallel line that goes through the point 0, 7 and 7, 0. Or you could do x plus y equals 0. That would be a parallel line that goes through the origin here. And eventually you'd get to a line x plus y equals negative 2. That would be the one that would go through this point, 0, negative 2. And you could also make another line x plus y equals negative 3. That would be the one that goes through negative 3, 0, because that's the sum of those two coordinates, right? So now the question is just, what is the distance between this line here that contains that point 0, negative 2, and this, our original line here, that was x plus y equals 8. And I think probably the simplest way to see that is to realize that this perpendicular line that tells us the distance between those two lines is going to be at a 45-degree angle, because each of these lines was also at a 45-degree angle. Whoops, I shouldn't have drawn it all the way to that one. It was this green one here, just from here up to here, right? So what is that distance? We can compute this distance here, and we will have a 45, 45, 90 triangle here. So we've got some distance x here, some distance x here, and then this distance is going to be square root of 2 times x over here, right? And this distance, which is square root of 2 times x, that is from 0, negative 2 up to 0, 8. So that's going to be a distance of 10, right? So we've got x square root of 2, x times square root of 2 is equal to 10. So that means x is equal to 10 over the square root of 2. And we don't like to see square roots in the denominator, so we multiply top and bottom by negative 2. And we get x equals 5 times the square root of 2. Yeah, because it's 10 times square root of 2 divided by 2. So x is 5 square root of 2. That's going to be this distance here, 5 square root of 2. All right, so that's one way to do it. I think there are probably a lot of other ways to do that problem, but that's kind of the way that was the easiest for me to see. Another way would be to just identify the slope of the line, and since we know the slope and the intercept, we could find the equation of this line, and we could find the intersection point and just compute with the Pythagorean theorem the distance between those 2 points. That's another way to do it, but hopefully that made sense. All right, let's go on to the last one. This is a nice and tricky one. This one says the diagonal of a square has an endpoint at 0, 0. Okay, that's at the origin here. And a second endpoint on the positive y-axis. That's this point here. The other diagonal of the square has its endpoint on the graph y equals ax squared. So that's this parabola here. So the other diagonal of the square has its endpoints. So both of these endpoints are on that graph. And then it says, if the area of the square is 128 square units, what is the value of A? Okay, so if the area of the square is 128 square units, so we've got this square, it's at a 45-degree angle, and its area is 128. So we've got a side length here, and since it's a square, all these lengths are the same. And we know the area is going to be s squared, which is equal to 128. And so that s, we can take the square root here, and that's going to be 8 times the square root of 2. And so if this is 8 times square root of 2, we know it's at a 45-degree angle here. Then this is 8 square root of 2 here. And we can figure out that this is 8 and this is 8. So that means that point, this point here is at 0, 0, right? That means this point is going to be at 8, 8. Okay, and then this point, of course, is, well, we don't really need to worry about those other points. This one over here is going to be at negative 8, 8, right? And I guess this one will be up at 0, 16. But in any case, we know that these 2 points are on this graph here, y equals ax squared. So y equals ax squared. And they want us to figure out the value of a. So we can plug in either one of these 2 points into this equation. Oh, just to be different, let's do the negative one, I guess. So this is going to be the y, so we're going to have a times negative 8 squared is equal to 8. All right, so this is going to be 64. So we have a times 64 equals 8. We can divide by 64 and we get a equals 1 over 8. And that's what they wanted to know, was the value of a. So our final answer is just 1 over 8. Okay, hope you guys enjoyed this video, and I will see you guys in the next one. Take care.